was so hard to start the history of computing. Where do you start? You start with the digits of the hand or the abacus, and you'll see at the end it's also hard to know where to end because things are happening so fast. And I don't know how many of you are familiar with something called Zeno's paradox, which says that a runner can never, Achilles can never finish a race because first he has to go half the distance to the finish line, which takes a finite time, and then after that it's half the distance again. In other words, an infinite number of finite distances, so he never gets to the finish line. And if you want to do the history of computing, by the time I got on the airplane in Washington and landed in Porto, something happens. Oh my God, this is a big. Forget everything else you heard about computing. This is the next big thing, and you have to. Any history that doesn't include that would be considered not a very good history. Well, I can't keep up with things. It's happening so fast, but I'm trying anyway, and we'll see how we get to the end here. When we last left off, we had engineers with a lot of semi-log graph paper predicting that there would be a computer on a chip. And somebody finally came up with a way of doing that, a man named Ted Hoff, who worked at Intel, that company I mentioned in Mountain View, California. There are many, many other people who worked on that, including some of the names which are on this patent. Stanley Mazur, Federico Fagin, a few other people whose names did not get on the patent. It's a complicated story, but it was not trivial to simply have a computer chip, have a chip with 3,000 components, and voila, you've got a computer. It was a little more than that. Here's the patent. You don't have to worry about the details, but notice there's an index register, which is kind of something fundamental about the computer, that you got to have an index register. But that's the patent. The story goes that there was a calculator manufacturer who wanted to build a line of calculators. Intel made a bid. Hoff had some experience with an small IBM computer, which had very, very primitive electronic circuits, but it did a lot of things with software. And in fact, it's a funny story. It was the IBM 1620, which is a completely forgotten. I don't think anybody in this room has a clue, ever heard of that before, but it was a small computer that if you wanted to add two numbers, instead of having a processing circuit that added, it simply looked up an addition table in memory and looked up the addition. That's your 2 plus 2. Oh, there's the number 4. Pulled it out of memory. Crazy, but it traded software for hardware in a very ingenious way. Hoff remembered that, and he said, "Gee, I can get a lot done with a very little amount of hardware if I be a little bit creative and figure out ways to do things in software." So they went back to this calculator company, and they said, "We will build a general purpose device which can do a number of things depending on what you store in what was called a read-only memory, ROM." And that's the genesis of the microprocessor. It was 4 bits long. That's all you need for binary coded decimal arithmetic. So 1972, they announced it. It was announced in electronics literature. The calculator company never really survived. Bizicom, they went out of business after a while. But Intel had the rights to commercialize the product, which they did. They followed it with an 8-bit microprocessor, the 8008 and then an 8080, and that everything went wild from that point on. The revolt of the killer micros we heard this morning, the 8086 architecture. So this is where it began in Silicon Valley, and began with very modest beginnings. So you've now got all the elements of a processor on a chip. So then, of course, you build a computer. Well, that again, it's easy to say in hindsight, how do you do it for real? And there were a number of companies who were sort of first out of the gate, and this is another one of these historians go crazy about who built the first personal computer. There was something called the Kenback, which was announced in a hobby magazine. The Mark 8, which used the 8008 from a professor at Virginia Tech. Intel itself built a system which they called the Intellect, which they would give, not sell, but give to engineers, which had all the basic elements of a computer so that the engineers could try out the microprocessor for some specific application. For example, a filling station that sold gasoline where you wanted to have different prices for the gas and different grades of gasoline. You would develop that software on this device, and then once you debug the software, you would burn it into a ROM, and then you would put it in a gas station pump. That was a computer. Intel didn't know it. They would give it away. They didn't know it, although it had, some people used it. Probably the first Micral was invented in France, was used in industrial applications. The Xerox Alto I'll get to later. So I have a very firm belief that the first computer was the Altair. The January 1975 issue of Popular Electronics had it on the cover. The story goes that there was a newsstand, and I remember this very well from my own student years, in the heart of Harvard Square in Cambridge, Massachusetts, where you could get magazines from all over the world. Lots of magazines. I think the newsstand may still be there, but I think they're only preserving it as a historical artifact because nobody reads magazines anymore, at least paper magazines. This issue showed up on the newsstand, and an engineer named Paul Allen saw it. He bought a copy. He rushed it to a student named Bill Gates in a dormitory at Harvard and said, "Bill, look at this." And they both looked at this. Their jaws dropped. To make a long story short, Gates dropped out of Harvard. Paul Allen quit his job at one of these electronics companies on Route 128. And they went to Albuquerque, New Mexico, where this computer was being sold. Now try to imagine if you're Bill Gates' parents. You've gone to all this trouble to get your son into the most prestigious university in the country. He calls you up and said, "Hi, Mom and Dad, guess what? I'm dropping out of school and I'm moving to Albuquerque, New Mexico because I believe that this is where the future is." Okay? So we've got 4 days of future ahead of us here. This is what Bill Gates said to his parents. They moved to New Mexico. And that's why, one of the reasons why I regard the Altair as kind of the first, because it grabbed the attention of people like Gates and Allen, but not just them. There are a lot of other people really saw the potential of this machine. It was a quite primitive machine based on the Intel microprocessor. Notice he calls it a mini computer because it was designed to look like a mini computer that was marketed by a company called Data General at the time. It looked just like a Data General Mini. He called it a mini computer. It was a mini computer with two fundamental differences. The first was the microprocessor. It did not use a whole row of integrated circuits like the minis did. The second thing is that it had semiconductor memory. It did not have core memory. So there it is, 1970, well, January 1970. Actually, it took a while before they were able to deliver. The company was overwhelmed with orders. It was a kit, and you paid $400, and you got a bag full of parts, which not too many people were able to actually assemble, but that's where it all began. Things begin small. So recently I heard a talk by Paul Allen about his experience there, and he said that the 1970, the era after the introduction of the Altair until the introduction of the IBM personal computer, he said they were the most creative, it was the most creative period in the history of American technology. That's Paul Allen. I believe him because you started out with this a bag of parts, and you had to program it in hexadecimal arithmetic. all right? Hexadecimal, I'm not sure who's a hexadecimal wizard today. To get it to do anything, even add two numbers, you had to program it extremely primitive. And you had to program by flipping switches and things. But between that and what we have today on your laptops and in your phones, all was done by incredibly dedicated, hardworking young people in the mid-1970s. They laid the foundation for all of that. They just pushed and pushed and pushed that technology. And there was this tremendous explosion of creativity, of different designs, all based around the Intel microprocessor. Another one was the Z80, which was an improved version of the Intel that was used in the Radio Shack TRS-80. There was a microprocessor that called the 6502, which was used in the Commodore PET. This was a computer that was very popular in Europe. This was a copy of the Altair, the MSI, which notice the switches and the lights, the blinking lights. You actually had control over every single bit of the processor. The Commodore, another Commodore machine that had a lot of games. Now here's the interesting thing. If you had a Commodore, you could play games, and we had talks about this morning. Nobody who had access to a multi-million-dollar IBM mainframe could play games. They simply couldn't do it. You could do it with a Commodore. And people did it. This was an incredibly popular computer. And 8 bits. And now I understand there's a whole retro fascination with 8-bit graphics because they look so cool. They really do. I agree. And then, of course, the Apple, 1977. A 6502 processor, Steve Jobs and Steve Wozniak developed that. Wozniak was and is a brilliant electrical engineer who figured out ways of paring down the components to be as simple as possible but still do the job, so make it a very fast computer. It also came with a disk drive that Wozniak wrote the software for the disk, so the disk, that floppy disk. Remember I mentioned that about IBM inventing the hard disk in San Jose, and the head of IBM said this is the most important day in IBM's history. What he didn't realize that this is the day that IBM began to fall from the top, because once you put a floppy disk connected to a PC, you have some competition with the mainframe world. And there they are, and I could go on with about 5 more slides of computers if I wanted to, but that was the burst of creativity. And what was happening, now that you have a computer on a chip, a microprocessor, what becomes really important is the software. Software comes to the fore. I mentioned Fortran and COBOL and Pascal in the earlier lecture, but now it's beginning to realize that that software can drive things because the hardware is now a commodity, relatively inexpensive. So interesting background about Gates and Allen. Gates is on the right, undergraduate at Harvard. They both had very extensive experience on one of those DEC, Digital Equipment Corporation computers, the PDP-10, which doesn't get a lot of history written about it, but extremely important. There's a story about Gates, which is a true story, because I've talked to some of the participants, that as a high school student, he had an internship in the Pacific Northwest where they had a series of hydroelectric dams on the Columbia River. And they had a computer network that was managing the distribution of hydroelectric power from those dams. Now, this is a network back in a time when networks were really quite new. A very, very early network of PDP-10 computers. The man in charge was from a company called TRW, Thomson Ramo Wooldridge. He had worked in the space program, And there's a story, and I interviewed the guy, so I know there's a very famous story in the space program about a Mariner spacecraft which was headed toward Venus, and it veered off course after the launch and had to be destroyed. They later discovered that the reason for the failure of the rocket was a missing hyphen in the guidance equation. This man left off the hyphen. The most famous bug in history. I went to interview him many years later, and in a hotel in LA, he pulls out his wallet, pulls out a New York Times story. For want of a hyphen, a spacecraft is lost. He carried that with him for his whole life, okay? And he became obsessed, some people say pathologically obsessed, with software quality. Gates was an intern with this man in the Pacific Northwest. And Gates, for many years, would tell people how inspired he was by this person's obsession with quality. It turns out that he may have embellished the story that turned out there was also a hardware failure, but there was a hyphen left off the equation. We know that for sure. So I won't give you his name, but you can find out. He passed away recently, but I had wonderful conversations with him. But anyway, okay, so what was their first product? They went to Albuquerque, and they told the people in Albuquerque, well, you need a programming language so people don't have to do this hexadecimal machine language stuff. You need a real programming language. You need BASIC. BASIC was developed for a time-sharing system at Dartmouth College in New Hampshire on a mainframe. So you had terminals that you would then access BASIC at a mainframe. It was a General Electric computer. But Gates and Allen realized, and BASIC has been disparaged and everything. They said, well, it was a very simple language, and you really couldn't do much with it. But he said that if you have a personal computer that's your own, that you bought, you can do anything you want with it. If you want to use it as a doorstop, you can use it as a doorstop. But you can do things in the software. You could peek. That means you could look at a specific location in memory. You could poke. That means you could take some data and push it into a location in memory directly. Now, in a time-sharing system, that would be the kiss of death, because you could just destroy the whole system by sending data into a place that was controlling the time-sharing. Everybody else would suddenly find their programs not working. You could drop out of BASIC and go into machine language if you were a real hardcore programmer, which some people were. And this command, so they added these commands to BASIC, and I think this is one of the things that people forget about. They think of BASIC as Microsoft's first product. Oh, BASIC, it's just this kind of silly primitive language. But it actually had a lot of power. And that's where, software comes to the fore with Microsoft. They found a company called Microsoft, and there's all these amazing stories about how the company, MITS, Micro Instrument and Telemetry Systems, they would invite customers into the place, and Gates and Allen would have been programming for days on end without sleep or showers or anything, and they'd be asleep on the floor. They're catching a nap on the floor, and the head of the company would have to shut the door of the room where they were sleeping so that the customers wouldn't see these guys. And I can imagine what they smelled like. But that's how Microsoft began, and that's how a lot of the PC world began. And again, I want to emphasize the connection to Digital Equipment Corporation, a company that's long gone now, but they really were pioneers, and that's that man, Gordon Bell. So what did the software look like? Well, it's interesting to talk about system software that we now recognize, like Windows. And when you look at the mainframe world, it was very, very different. The mainframe world, you saw that picture of the IBM mainframe, row after row of tape drives, disk drives. A mainframe was characterized by these units called channels, which directed input and output to those storage devices. Well, a personal computer only had one disk or two disks. It didn't have a lot of input and output. It had a little, maybe a screen, a terminal or something. The operating system for a personal computer was strictly get the data in and out of the processor into a location on a floppy drive. That's really what it was all about. Everything else came later. So that was not a trivial problem. You had to format the disk and find a place on the disk where there was room, and then let the processor know that the data was stored here, here, and here, and link it together. So that was a real programming challenge. The early operating system was called Control Program for Microprocessors, CPM. Early WordStar, word processing, database, spreadsheet. They had use a dot matrix printer. And optional, and this is optional, I'm going to get to this later on, the Hayes modem that lets you communicate. So here's what WordStar looked like. WordStar is highly flexible and very visible. You had a set of, you'd hit the Control key and S to move left, Control D to move. It was, believe me, once you got the hang of it, it was very simple. You didn't need a mouse. Forget the mouse. That's for wimps, right? Nobody needs a mouse. So where are some of the control? Well, anyway, the control characters. Okay, so here you go. This was up on the top of the screen. This was down on the bottom. Here's the advertisement for CPM, operating system that the 8-bit computers used. And that's where it all began. Now, Microsoft, meanwhile, is moving on. They're trying to produce other compilers besides BASIC. And they realize that IBM is coming out with a personal computer of their own. And here's IBM, this mainframe company, buttoned down, white shirts, narrow ties and everything. And they say, well, we see this PC, we got to do something. One of the salesmen bought Apple II computers and put one on every executive's desk. Said, here, play with this thing. You better get used to it. So they decided to come up with a PC of their own, which they developed not in New York, where IBM's headquarters was, but down in Florida, away from the top brass of the company. And they needed an operating system. The story goes, and this is legend, that they went to CPM, Gary Kildall, the head of this company, and they said, can we license your operating system? And CPM, they refused. They said, no, we don't. And there's a whole bunch of legends. The story goes that the head of the company was flying his airplane for fun and didn't want to come down or something like that. The reality was, as far as I know, is that they were very nervous about signing away anything to the IBM Corporation because they had heard correctly that IBM was quite ruthless in their business practices. So they went to Gates, or Microsoft, and Gates said, sure, I'll give you an operating system. Well, he didn't have one. But hey, whatever. He went to a company in Seattle which was developing an operating system for, this was a 16-bit computer, and he bought that system. And it ended up being MS-DOS, which for a while was one of the most popular system software in the world. So there you go. There's the real beginning. Microsoft in 1978 moves from Albuquerque to Seattle, and there they are. And the company, we have some Microsoft employees in the audience. It's a big company. And this is where it began, with the operating system for the PC. Now, the PC was one of the most profitable products for IBM, but it also was the downfall of IBM in a way, not the extent of their downfall. It radically restructured that company. Interesting thing, because what was it about the PC that was so unusual? It used an Intel microprocessor. It was not an IBM microprocessor. It used a floppy disk that was made by a Silicon Valley company. It was not an IBM floppy disk. It used memory chips from Fairchild or Intel, so it wasn't IBM's memory. So all the parts were made by somebody else. And eventually, an undergraduate in Dallas at the University of Texas named Michael Dell said, hey, if they can do that, I can do that out of my dorm room. I'll just go to these suppliers, buy the parts, slap them together, and put my name on it, Dell, and it'll be cheaper, which is exactly what he did. So that's the beginning of Dell and the beginning of end. And some of you I can see some Dell computers out there. The beginning of the end of IBM's dominance that kind of drove, this was right in the middle of this antitrust trial where the federal government was saying, oh, you've got to be broken up, you're too big, no one can ever challenge. Well, here's the end of IBM's dominance right here with MS-DOS and Dell and the commodity. These are commodity disk drives. Anyway, so there you go. 1978, they moved to Seattle. So we have an interesting thing here. And I talked in the first half about the top-down of computing coming from people like Hilbert and Turing, who were doing this theoretical analysis of logic. The bottom-up are electrical engineers who were trying to put something together that can actually calculate. They meet in the 1940s in the form of an electronic computer. So this happens again on another level. From the top down, you have these high-end computers which are derived from mini computers that are developing all kinds of very, very cool innovations. This is a story which came up in the comments, the question and answer session earlier today about the role of the military. The Defense Department had something called the Advanced Research Projects Agency. It was founded in 1958 after Sputnik, after the Soviets orbited the first Earth satellite, then later orbited the first human being and the first woman in space. They said, okay, we don't ever want to let Sputnik happen again. That was their charter. Do whatever you can, just don't let that happen again. And they had a lot of money. They were funding a lot of innovation in computing. In 1970, however, and this is an interesting story because this is sort of relevant to where we are today, the United States was involved in the war in Vietnam. It was going very badly. And the Congress, the US Congress, said, well, why are you funding all these pie-in-the-sky projects when we really need to focus on what's happening in Vietnam right now? Why are we losing in Vietnam while you're funding all this stuff? There was an amendment to an appropriations bill called the Mansfield Amendment that said no more funding of projects unless they have a direct military application. A lot of people left DARPA, Defense Advanced, and they moved to a place in Palo Alto that was run by Xerox, the copier company. They made copiers. They were the world famous, highly profitable manufacturer of copying machines. Their top executives said, we are nervous about the computer that may be the end of paper. That's what they were thinking. Is this the end of paper? Maybe. We will fund a laboratory, and they decided to locate it in Palo Alto. They called it the Xerox Palo Alto Research Center, where they said, well, DARPA, you're coming, we'll hire all these people who are no longer at DARPA. Here, come over here to Palo Alto and invent the future, which is what you're going to do the rest of the week. And they came up with a computer called, these are some guys' bicycle there, very laid back. Xerox headquarters was on the East Coast, where everybody wore three-piece suits and white ties and black ties and white shirts. Very laid back, but they came up with some very interesting innovations. Windows, the mouse, which was invented elsewhere in Palo Alto, but they commercialized that. The Windows, not the Windows operating system, but the notion of overlapping windows selected by the mouse. Ethernet, and this is again a fundamental shift from time sharing, where you had one big giant computer and people shared pieces of it. Ethernet popularized the client-server architecture, where you had a smart device, a PC, that was connected to a server that served, that kept data and other software. So Ethernet, extremely fast networking, that came out of there. Tremendous, but it was a very high-end, expensive system. They also invented the laser printer. Lots of things. Object-oriented programming. One of the engineers there was a man named Alan Kay, who developed the Smalltalk programming language, which is the origin of object-oriented programming. He had this quote. It said, and you've heard this quote, I'm sure. The only way to invent the future is to invent it. What did I say? Oh, the only way to predict the future is to invent it. Sorry, I got it wrong. The only way to predict the future is to invent it. That's Alan Kay. Well, I can let you decide whether that was correct or not. He certainly deserves some credit for, he also came up with the idea of the laptop. So hey, that's not a bad thing for your resume. Also, the mini computer was growing up. Those primitive PDP-8s ended up with a 32-bit word computer called the VAX, and some of you old-timers can remember the VAX. It was a very, very powerful computer, 1 million instructions per second, which at that time was really something. And it had two operating systems. One was called VMS, Virtual Machine Operating System, that was designed by DEC. The other was Unix. And Unix has its own story, and I don't know, I guess I have time to talk a little bit about that. Unix was developed at Bell Labs, and I talked about Bell Labs last time, that they were developing an operating system that was to serve time sharing, where they had very, very elaborate restrictions so you couldn't mess around with somebody else's program. Walls of access and security and everything like that. File systems that you wouldn't crash. If you crashed one, you wouldn't crash the other, so forth. And in some ways, it's very related to cloud storage today, where your programs may be stored right next to some high-security Visa, MasterCard storage, and you're on the same disk, but you're partitioned away, something like that. Well, anyway, that was Multics failed. It didn't quite work, and I talked about what's good about failure. Well, two people at Bell Labs looked at Multics, and they said, well, there are some things about this that are really good. Let's see if we can come up with something a little simpler. They had an old, not a VAX, but an old PDP computer that no one else was using. This was at Bell Labs in Murray Hill, New Jersey. They very slowly bootstrapped a system called Unix, which was a sort of pun on Multics, that had a tremendous amount of personal power if you knew how to use it. Obviously, it was not that easy. You could do all kinds of damage. You didn't have that security, which is, of course, one of the problems we have with the internet today. And that's where Unix came from. And they offered Unix, and this is another very interesting story, that DARPA funded the installation of Unix on these computers. And the head of DEC, a man named Ken Olson, he couldn't understand why anybody would want Unix when they had VMS, which was a much superior operating system. And he said, Unix is snake oil. Well, he got that wrong. But I don't want to disparage people. Who was going to know? Who was going to know that this was all going to happen? So this was the top down. Now, what's going on the bottom up? The bottom up is Moore's Law. Personal computers are getting better and better. So Steve Jobs visits Xerox Palo Alto Corporation Center. He sees the Windows up, he sees Windows, he sees the mouse, he sees all that stuff, and he says, I would like to put this on a PC. Now, the Xerox machines were massive, expensive mini computers. He wanted to put it on something really, really simple. And now there's legends about this. They said he stole the idea from Xerox. Well, that's not true. He had a license. They paid Xerox for the rights to go there and visit and get some of the technology. And then of course there's this famous quote by Jobs, great artists steal. And he compared himself to Picasso. Picasso, he stole all this primitive art from Africa and all that. Well, that's Jobs, crazy guy. But you need crazy guys, right? But he said, we're going to put it on a PC. And he told the people at Apple, make this happen. Well, they pulled their hair out, but they did come up with the Macintosh. Meanwhile, the microprocessor is getting better and better. And I'm jumping ahead a little bit here, but the Windows operating system, Microsoft tried to imitate the Mac with Windows. The first ones didn't work very well. Eventually, they get better and better. Intel, meanwhile, comes out with a high-end microprocessor, the Pentium, which has that kind of VAX type of performance, workstation performance. And they hire the architect of the VMS operating system, a man named Dave Cutler, who comes up with Windows NT. And at that point, Windows is now fully comparable. Windows combined with a Pentium is now fully comparable to those high expensive top-end workstations. Goodbye workstations. Goodbye Xerox. Goodbye digital equipment, Data General, and all those other Sun. I don't know if anybody ever used a Sun workstation. Because you can do it on a PC with Intel processors and Windows NT. So here it is from the bottom up, moving upward. And again, I mentioned Gordon Bell's semi-log graph paper. He was predicting a lot of this happening. It was an inevitable consequence of Moore's law, but it wasn't inevitable without people like Steve Jobs to come and push it into reality. And the Mac was a tremendous tour de force, even though the first Macs were quite crippled. They only had a single floppy, and in order to install software was a nightmare. You had to keep swapping floppies. I won't go into that. It was very crippled in a way. So that was the story in the 1990s. But I'm jumping ahead of the game. If you recall my first talk, where I said the computer of the 1940s was a convergence, calculating from Pascal, data storage from Hollerith and IBM, control. Okay, this merging of things that had been done by different machines earlier. Now we have another convergence. Communications. Why would you want to use a computer to communicate? What a silly question. The US telephone network was the best in the world, and the European networks were pretty good too. AT&T, as a regulated monopoly, was forbidden to enter the computer business, but they poured an enormous amount of research into making the telephone reliable and making the voice quality as good as possible. It was an excellent network. Somebody comes up with the idea of hooking up computers. Now, I want to just mention that in those days, if you wanted to send data over a telephone line, you call AT&T and say, I want a telephone line of a certain capability from this city to that city. And they, okay, it'll cost you this much. They'd set you up. And only 500 bits per second, 2,600 bits per second, something like that. At the same time, and I've done this research about the the Internal Revenue Service, which collects taxes. They would collect tax data around the United States at centers. They would put them on tapes, IBM tapes. They would put the tapes in an airplane and fly them to a central processing center near Washington, D.C. The airplane was flying at 600 miles an hour. So, and I once did the calculation, I didn't bring it with me, I'm sorry. What is the bit rate of carrying an airplane full of tapes at 600 miles an hour across the country versus trying to send that data at 500 bits per second on a telephone line? you can see there's a it's a no-brainer, right? Why would you want to do that? Why would you want to do that? Well, some people against that, well, there's a good reason. So again, ARPA decided with the funding, they had Defense Department money, we are going to network computers. They had some very simple things, and the fundamental idea, which was simultaneously developed by a researcher in Santa Monica, California, the RAND Corporation, a semi-private organization funded by the Defense Department, and a man named Donald Davies in England, in the UK, who worked for a telecommunications company in the UK, that said, if you want to connect computers, the AT&T method is you set up a circuit. You say, okay, I'm going from here to here. It's going to go through this city on this wire from here, and while we're set up, we're going to communicate the data. Davies and Paul Baran, both independently came up with the idea, no, why don't we split the message up into small chunks called packets. That was Davies' name. And just send it by whatever route is most efficient at that particular moment in time. Now, AT&T couldn't understand how you could make a thing like that work. It sounded crazy because you had to reassemble the packets at the other end. Baran, and there's a myth about him that they said the internet was invented to survive a nuclear war. The idea was that if a nuclear war with the Soviet Union were to happen, the circuits would be cut. And Baran said, well, you could route them some other way. I talked to Baran about this, and he said, no, that's not true. It was designed to prevent a war. There's a difference. He said that in a time of a crisis, like the Cuban Missile Crisis, communication lines break down. You can't get through. The phone call doesn't go through. It gets overloaded. This happens when there's a flood or a hurricane or a storm. The phone lines can't get through. If you split up, if you distribute the processing, the message will get through somehow. And that was his idea. Again, it was simultaneously conceived by an Englishman. The idea of packet switching. It was demonstrated in 1972, and AT&T couldn't believe that this was going to work. It went against all of their sophistication in communication engineering. Finally, the people at ARPA set up a demonstration in Washington, D.C., where you could actually log onto the ARPANET, and you could try out remotely log into a computer across the country, all kinds of things. And notice it's very much East and West Coast. Utah is where Alan Kay did his graduate work. That's why Utah's there. Stanford Research Institute, where the mouse was invented. Stanford, UCLA, where the mathematics of packet switching was developed by a man named Leonard Kleinrock, who was one of the sort of forgotten fathers of the internet. RAND, I mentioned. System Development Corporation, another software house. On the East Coast, Harvard, Bolt, Beranek, and Newman, another research institute in Cambridge that did a lot of the glue building the ARPANET. MIT, Lincoln Labs, an Air Force lab, Case, and Carnegie Mellon University. So very, very simple. There's the beginning of it. A convergence of communications with the computing as it existed up until then. But again, this is high amounts of Defense Department money coming from the top down to the top universities in the country, Carnegie Mellon, Stanford, MIT, UCLA. What's coming from the bottom up? Well, there were networks coming from the bottom up. If you had a PC and you could get a Hayes modem to plug in and you had a telephone, you would dial a number, listen for this high-pitched squeal. As soon as you heard the squeal, you'd put the phone down in a cradle, and you would connect at 300 bits per second, not the fastest connection in the world, with a local telephone network. and running simple software, and you had these local, what they call bulletin board systems. It's interesting that AT&T had a very strict monopoly of the phone system, and there was a question, are you allowed to send computer data over the phone? And AT&T thought about this and said, well, it's just sound. As long as it's sound within the audio range, how can we stop it? So they said, okay, go ahead. That was a really critical decision by AT&T. So you had the cradle, you put the thing in the cradle, and you ran very simple software. And in the United States, local calls were free, and you could stay on as long as you wanted. It's very important. Long distance calls were expensive, and they charged by the minute, but they were cheaper at night. This was the structure of the phone system in the United States. Obviously all gone now. But what people would do is they would gather data during the day locally, and then at night they would bundle it and send it across the country at lower rates. And they called it FidoNet after the name of a dog, Fido. It would fetch the data. So there's this really primitive hobbyist hacker world coming up from the bottom, and the two had little to do with each other. The ARPA people didn't even know about this. And the PC people, they had no access to ARPANET. In fact, there are cases where in universities where computer science professors had no access to the ARPANET. Their colleagues in the engineering department who had defense contracts could network and go on and do all these crazy things. The computer science people couldn't. They didn't have the security clearance. They didn't have the contracts, the military contracts. So it was a really crazy situation. But it shows the skewing of history by ARPA, incredible, which we can talk about maybe afterwards. But it's, that's where it came from. So I'll back up. I mentioned the protocols. In order to make all this work, you had to have some way of routing the packets, addressing them properly, reassembling them at the other end, making sure that if an error was made during transmission, that you would retransmit the packet that didn't get through. All of that was worked out, and out of that comes the internet. Now, who is the inventor of the internet? And there's a standard joke in the United States that whenever anybody talks about the internet, they always make a joke about Vice President Al Gore. Al Gore invented the internet. Well, he never really claimed that he invented the internet. I'll get to him in a minute. There are so many people involved with the internet. Where did it all come from? I would say it's this Harvard professor named J.C.R. Licklider. I don't know how many of you ever heard of him. He wrote a series of papers, The Computer as a Communications Device. This radical idea that this machine, which was calculating, could actually be used as a communications device. He wrote a paper about what he perceived as symbiosis of a human being and computer. I apologize for the gender man, human-computer interface. That there had been research done in the 1950s and 60s on artificial intelligence where the idea was to create a computer that was intelligent like a human being, like a robot. You know, smart, a computer that was as smart as a human being. Licklider said, no, that's wrong. What you want is a symbiosis where the computer does what it does well, human beings do what human beings do well, and they work together. That was his idea. And he pushed it and he pushed it. He had a high position at ARPA, so he had money. And that's a very important thing. My version of this story, which I've written about in this book, which hopefully will come out in a Spanish edition soon. I don't know about the Portuguese edition. But there was a conference being held in a resort in 1962 on military communications, and all these bigwigs were there, and they took a train, and they didn't have email or cell phones in those days, so on the way back from the resort to Washington. All these people were stuck on a train. Licklider went from one car to the other, sort of shaking people, saying, "You've got to do something about this, okay? And I've got the money." That woke people up. "I've got the money." So by the time the train got to Washington, bingo, a whole bunch of proposals went into ARPA, eventually leading to networking. So it's 1962, so I'm obviously jumping back and forth in time, but that's where it came from. What did it look like? Well, instead of the flexo writer that I mentioned in the first lecture, they used a teletype. They modified it for communications. It was not really meant for a computer, but with a little bit of loving care, it could be used. One of the researchers at Bolt, Beranek, and Newman in Cambridge was developing a way to send messages from one ARPA node to another, and he noticed a @ sign. So that's the only preposition on the teletype. There's only uppercase, no lowercase, and a few special symbols. So he came up with the idea of having an @ sign separate your account from a network node, the beginning of email, 1970. Totally unforeseen. In fact, it wasn't even clear that you were allowed to send email because that was considered a non-military use of the network. But it totally took off. And like I say, how could we have organized this conference without email? Here's a later map. Again, these concentrations with a satellite link to Hawaii, but East and West Coast, Stanford, Southern California, Boston, and Washington. There's the National Security Agency, Naval Research Lab, the MITRE Corporation, the Pentagon, and there's an interesting link by satellite to Norway and to London. And this is very interesting here. This link to Norway, again, people don't talk about the Cold War dimension to all this. Norway was a site where there was a lot of monitoring of Soviet atomic bomb or hydrogen bomb capability and Soviet military capabilities. It was very important for the US military to know what the Soviets were up to. So they established a satellite link to Norway to send that data. So that was the first international node, and London, and well, Hawaii's not international. So there's what it looked like. Now, what were the machines that were used? They were PDP-10s, IBM mainframes, no PCs. There were no PCs on the ARPANET. None at all. None. So that's what it looked like. So in 1973, the original packet architecture was beginning to show its age and not working very well. So these two people, a mathematician and an engineer, convened a conference in California where they decided to come up with a new set of protocols, which they eventually split in two: transmission control protocol, internet protocol. In 1973-74, they came up with this. They published it. It's published. Anybody can use it. The internet is free. You can make your own internet. Nobody owns it really. And in 1983, ARPANET switched over. So it switched from being a single network controlled by the military to a network of networks. In other words, anybody who had a network could now join this internet as long as you use these protocols, Vint Cerf and Bob. So these are sort of the fathers. I consider Licklider the true father. These are considered the fathers of the internet. So we now have a real internet. Now let's keep going. Again, success has many fathers. Here's my friend Al Gore. Oops, back up. Now, what did he do? It's very interesting what he did. He was a senator from Tennessee. His father was a champion of the interstate highway system, the super highways for cars. Al Gore, his son, said, let's see if we can do that with computer networks. But what was he thinking about? He sponsored legislation that said, let's link computers together so that people in less affluent parts of the country could access supercomputer capabilities that were funded by the US government. A very, very different notion of the internet from what we now take for granted. Nowadays, there's supercomputers pretty much, there's 500 of them, right? Back then, they were more scarce. That was his idea. And the other thing that he said, and this is something that doesn't get in the news, is that at the time, this TCP/IP protocol was put together, funded by ARPA. They said, oh yeah, this is working, but it really has some problems. And we all know what the problems are now of spam and phishing and all kinds of viruses and everything. We should have a better set of protocols. Pioneered by European researchers, they had something called OSI, Open Systems Interconnect. Very, very tightly structured set of protocols. You could never hide your identity, for example. If you sent a message over OSI, you had to give your real identity. People could find you. You couldn't do spam. You couldn't do phishing or any of that stuff. And Al Gore said, okay, well, we've got TCP/IP, but we're going to move to OSI really quickly. And he sponsored a bill. The controversy is that people thought that just because he sponsored this bill that he was the so-called father. He wasn't, but he played a very important role. The Unix operating system that I mentioned before is the glue. That came out of Bell Labs. And what happened with Unix? Again, we have these very interesting situations of the internet you don't have to pay a royalty to join the internet. You don't have to pay, well, originally you had to pay a royalty to Bell Labs to use Unix. This is a joke. This is a license plate from the state of New Hampshire that one of the Unix developers had. He kept getting stolen from his car. A guy at MIT named Richard Stallman said, hey, he got very frustrated when Xerox would not allow him to change the software driver for one of their printers. He said, heck with you people, I'm going to write my own software and make it free. So he said, I'm going to write a free version of Unix. And more important, I think this is more important than anything else, he said that I am going to develop a licensing agreement where anybody who uses this software, not only do they not pay for it, but they are not allowed to ever charge for it. It has to be free. And this is called GNU. GNU's not Unix, GNU. And his real contribution to me was the GNU Public License, or GPL, which we now call open source. The stuff is free. So much of the wealth of Silicon Valley comes from their creative use of free resources. Very important concept in the history of computing. The ability to use free resources and make money off of it. The GNU Public License said you can make money off it, but you can't own the rights to any software that has a GNU Public License. Stallman never completed the entire Unix system, but a young kid in, this is Norway, right? Finland, Linus Torvalds. He completed it. He said, oh, I'm just having fun. And unlike Stallman, who used a high-end workstation, he used a cheap IBM PC that he financed on the installment plan. And he came out with Linux. So here we are, free. Bell Labs eventually gave up. So we have the glue of the internet is Unix. The internet was originally, transferred from the military to the National Science Foundation, which is a civilian agency that funds scientific research. But as a government agency, they had a prohibition against any commercial use. Well, that wasn't going to last very long. And eventually, in 1992, an amendment to the funding of the National Science Foundation, there was a couple of words inserted. It can use it for other uses that opened up the whole internet to commercial use. So very small wording in this bill. Here we are. This is where it all came from. So again, as if that's not enough, another free resource, the World Wide Web. It is not the internet. It's a program that rides on top of the internet by this gentleman, Tim Berners-Lee. This is the guy who invented email, by the way. This was at a museum celebration. There's a teletype behind him. This is CERN. He said that at CERN, there were researchers from all over the world speaking different languages, meeting together for coffee. And he said, why can't I do that with the internet? So he came up with the World Wide Web. So again, you do not have to pay Tim Berners-Lee a dime every time you log on to the World Wide Web. Facebook does not pay him. Google does not pay him. It's free. The World Wide Web is a free protocol that runs on top of the internet. So this is really, Berners-Lee, but he doesn't mind. He's doing okay. I don't know. He got some financial awards, but he's not a gazillionaire like Zuckerberg or Gates, but he's doing okay. But I think the point is that if he had tried to charge a royalty, let's say a penny, for every time you logged onto a web server, first of all, imagine how rich he would be, but secondly, the web wouldn't have gone anywhere. In fact, before the web, there were other ways of accessing the internet that you probably haven't heard of. So here again, these crucial people like Berners-Lee, like Stallman, like Torvalds, who had this belief in freedom within certain restrictions. Of course, if you want to use the web, you have to adhere to the World Wide Web Consortium about what they say is allowable use. And if you wanted to sort of splinter off and create your own for-profit version of the web, you'd have a little bit of trouble doing that, although people have tried to do that. So here we are, we're moving rapidly into the present day. And you recall where I talked about this proliferation in the 1950s of computers that used this inexpensive drum memory. Then this proliferation of PCs in the 1970s when the microprocessor became available. Well, now we have this tremendous explosion of web stuff. They call them portals because the web had deficiencies. It has deficiencies. Every time you go to a web server, it doesn't know that you've been there before. Although Netscape came up with the idea of a cookie to track you. There was a sense that you got lost in cyberspace. It was just all this huge amount of data out there. How did you know where to go? So people came up with something called a portal. Yahoo, this is GeoCities, where you try to put some structure on it. Netscape, which came out with a browser. AOL was a very famous company. They're still around, sort of, I don't know. Training wheels for the internet. They kind of helped you get into the internet. But I think Facebook is a modern version of AOL. It's for people who don't really want to go to all the trouble of actually getting their hands dirty anyway. But will Facebook survive? That's a question I'll leave to other people. It didn't have any way to search for things. So the early search engines, Alta Vista, ASCII, these are gone. Alta Vista was really incredible. It was the first one that really showed the power of search engine. Google came up with the idea that you would rank a search based on how many other people cited it, which goes back to a mainframe application called Science Citation Index, which is still used today for tenure and promotion, which causes a lot of trouble among academics. Somebody comes up for tenure and say, well, I published these papers. The tenure committee says, well, nobody's ever cited your papers. No tenure for you. Bad idea. Or here's this paper that you published. Everybody cites this paper. It's considered, you can't write another paper without citing. That person gets tenure. And that came from a guy named Eugene Garfield, who came up with science. This was all done on an IBM mainframe, but Google sort of carries that forward. The search rank delivers the ranking based on how many other people are linking to it. Berners-Lee hoped to be able to write to the web as easily as reading it. That never happened with him. But the blog was invented in the late 90s, so now anybody can go to Blogger and you can create your own. And we all know about blogs. Again. Okay, so here we go. Here we are. We're rapidly coming up to the present day. So everything's all hunky-dory, right? I could stop here, but I won't. Why? Because things are still moving. So we talk about convergence, 1940s, convergence, communications, 1960s. By the time I got on the airplane, by the time I landed in Porto, there's another convergence, right? And what is it this time? Geolocation. When we walked from the hotel to this venue, I had a paper map. The people I was walking with had Google Maps. They're going, okay, go like this. Oh, no, go like that. They had the map. I'm now working on a book about the history of GPS. Modern cell phones have GPS in it. The European Union is building a system called Galileo. They can now locate you within a few meters. But GPS and Galileo, if they have trouble working indoors, you're located by triangulation with cell phone towers, also Wi-Fi. So you've all got your phones. You look at your phones, it knows exactly where you are. They can track you. And they have something called micro-electromechanical systems in your phone, which means gyroscopes, accelerometers, things that were used by ballistic missiles, and things like that. So what does all this mean? This convergence now means that you have, again, piggybacking on the free available of GPS and soon to be Galileo. I think Galileo, the European Union, originally said we're going to charge people for the use of Galileo, but then they realized they can't do that because GPS is free. Using that stuff, you can do all kinds of things, like Uber. Uber cannot exist without GPS because you don't. You used to be a cab driver. You had to memorize the streets of the city. So I want to go. The cab driver had to know where, or he had a paper map. Now, an Uber driver can go into a city he or she's never been in. Say, I want to go over here. Okay, put it into your phone. Off you go. Drones. Not just military drones, but Amazon now wants to deliver packages by drone. That's a big deal. I mentioned earlier autonomous drones that are small. If there's no person in it, you can do all kinds of weird stuff with it. Drones are taking off like crazy. Autonomous cars. Who needs a driver? You got GPS, right? It's all happening now. As a historian, you have to be careful. You don't want to jump the gun, but it's happening now. Autonomous aircraft, are you going to get it? I can tell you one thing, if autonomous trucks take off, goodbye railroads. It's a crazy, crazy world we live in. So here's the convergence going on with and I use the iPhone as a kind of symbol. So I'm getting close to the end here. A professor of mine once said that, okay, well, let's look at this. What has happened in the past 10 years thanks to the iPhone and the laptop? Now, I apologize for the American, and I apologize for putting so much text on the wall. I'll read a little. What has disappeared? Encyclopedias, Wikipedia. Broadcast television. Why watch broadcast television when you got YouTube? Classified ads. Film, I talked about the Kodak bankruptcy. Michelin guides. Do they have Yelp in Europe? Yes? No? A version of Yelp. It's a weird program. Okay. Movies. You stream them on Netflix. Paper maps are gone. Music. You used to go to a concert, there'd be a band, a guitar player, a bass player, a drummer. Now you go to a concert and there's somebody with a laptop. That's the whole band. What? Taxi cabs, broadcast radio, well, podcasts. The BBC has shut down a lot of its foreign service. Travel agencies are gone. Weekly news magazines are gone. Wired telephones, okay. Yellow pages, I mentioned. College professors, this might make a few people nervous. I put a question mark there because if I'm speaking in front of an academic audience, it might cause. Hotels, Airbnb. Journalists, money, we mentioned Bitcoin. All of this is being dissolved. And now, tune in 5 years from now and see what this slide looks like. I can't wait. Well, I will wait. We'll see what happens. Some of this may not happen, but so I'll conclude. Computing is the universal solvent of technology. It dissolves everything it touches. But what is the container that can hold a universal solvent? I don't know. And I guess we'll find out the rest of the week. Enjoy the course.
So we have some time for questions.
It's more of a comment than a comment than a question regarding the future of computing on your previous slide. I would be cautious when trying to replace with technology or computing infrastructures anything that requires creativity or critical thinking, such as journalists and college professors. So everything else I agree, but we just, because people are starting to ask, computers will replace human jobs.
Yes, yes.
And it might be a discussion that might come up. But yeah, so anything that involves creativity, I think is very, very far away in time. And it's something that I guess will be a topic of discussion at some point, I imagine.
I assume we'll be discussing that later in the week.
It's just a thought about, okay, you kind of build this path up, starting from Moore's law and coming all the way to here. I have a comment about, for instance, the amount of useless computing we have today. Every time I said I work with IT or I'm a programmer or whatever, somebody says, "Hey, my computer is not working. Can you help me?" Yeah, just install Linux on top of that thing. You don't have to buy a new one. For browsing YouTube and writing emails, you don't need like an i7 last generation processor to do processor. And also, well, this is not just about useless technology or technology that is on the hype just because of advertisement or the way we started to thinking and feel about, the iPhone or the smartphone and so on. But it's also like in terms of logistics and environmental and even from an engineering point of view, sometimes it's stupid. We build things that just because people are going to buy them, but that are not efficient or are not optimized even for their main purpose. Yeah. Cars are an example of that. So that's just an open comment about
maybe if Moore's law comes to an end, people will take a breather. And it might be worth doing that. Take a pause and see where are we, maybe slow down a little bit. I don't know if that's going to happen or not, but I think it would be a good idea.
Well, I would like to say that there can be such thing as too much of a good thing. Now we have such a surfeit of information that it becomes really difficult to filter it and figure out what is true and what is not. Actually, this increases the intrinsic value of what you actually know by yourself without Google. After all, as Napoleon used to say, you cannot trust everything you find on the internet.
Yeah, that's certainly true. I hope you don't suffer the Drudge Report. We have it in the United States. It's totally destroyed journalism. But anyway, good journalism.
Yeah.
Well, the Drudge Report is an aggregation of internet sites, yeah.
So, yeah, on one side you had Bill Gates getting very rich with Microsoft and so on, and then you mentioned all these people who developed the infrastructure behind internet,
Yes.
and they weren't making a dime on it. And you mentioned it was because they thought that's the only way the internet will actually become global and people will use it. But was it really the only motivation? And it's so different, right?
Yes.
How rich some of them got and how
Gates
other...
was a very good businessman, and he wanted to have a successful business and hire a lot of people. He was very happy to be able to hire employees and pay them good wages. Berners-Lee, he works at an institute in Cambridge, Massachusetts, and he's gotten plenty of awards. He's been knighted by the Queen of England. I'm sure I've met him. He's very satisfied with his place in the world. He's not poor. Maybe you don't really need a whole lot of money to be happy. I don't know. But Stallman is a very strange character. I don't know if anybody's ever met him. He's one of the... there's a couple of people. There's one guy, I won't mention his name, but if you go to his Wikipedia page, the Wikipedia page says, "This gentleman is known for his poor dental hygiene." And I've met him, and he doesn't shower very often or something. But he's changed the world, okay? So I think that you can give him a pass on that, maybe. He's not wealthy. Stallman is not wealthy either. He did get a Genius Award, the MacArthur Foundation Genius Award, but he's not a wealthy person by any means. So, but he changed the world. He really did.
Hi, thanks for a very inspiring talk. I would just like to correct the previous gentleman. The person who said, don't trust everything you see on the internet was not Napoleon, it was Abraham Lincoln.
It was who?
Just for your information. It was Lincoln who said it, so that you know. Can I just go back momentarily to the previous comment that I fundamentally agree with. Maybe there's something to be said about critical thinking and creative process in regards to technology. So the examples at stake were professors and journalists. While agreeing with it, what I think we can and should consider here is how the technologies themselves impact on the expectations of these activities. So what you see fundamentally happening at the same time is both academic research and teaching and journalism changing and evolving as a consequence, being streamlined and possibly, and let's keep it on the hypothesis mode, being devalued in their critical and creative aspects, at least in terms of the expectations. That's it.
Yeah. Well, we are in an art school here.
So I really enjoyed when we were talking about those convergences. So there's something converging that in a certain way changes how computation is being made. I think we've seen very recently another convergence, which you didn't mention, but I kind of wanted to ask your opinion about. In the last maybe 7 to 8 years, mostly due to the fact that the gaming industry is so powerful.
Yes.
we've seen this almost the introduction of a totally new, not a totally, but a different way of making computation, which is by using GPUs, which are now so cheap that allow most people to have a kind of a micro supercomputer at home, right? So how do you see that, and what's the impact of that? Because in terms of, in some certain fields, like for example machine learning, it's been huge. It totally changes the field, totally.
Well, yes, hearing the lecture this morning, I almost felt like I had to add something there, because it really, these GPUs are really a fundamental shift away from the von Neumann architecture that I focused on, and the reality, the realism of the graphics, and the way you can immerse yourself into these environments is very, could be frightening if you want to feel that way, if you're an old timer, or not. It could be exciting if you're a young person looking at what's happening. That's the place to go. Yeah, definitely.
But my question is more like, it was mostly because we have this new industry, or at least an industry which became so powerful. So the gaming industry is about 1/7 of the size of the air industry. So if you combine all the air transportation in the world, the gaming industry is 1/7 of that, which means it's huge, right? So it was mostly something that also comes from, you know, bottom up, right? It wasn't anybody saying, okay, let's build these sort of supercomputers. It was something that came from the consumer market. So what do you see, what other forces you kind of are observing now that could take us to the next step in terms of computation? Because we're already at the point that we have supercomputers. So what could be the next step in terms of, what are the driving forces for that?
Well, from gaming, and I've mentioned the Commodore 64, these 8-bit computers, which have a sort of retro appeal to them, but I guess moving into some kind of science, which is only in science fiction now, where you literally step into this computer world and you no longer are interacting with human beings in any kind. I don't know. I'm kind of, in some ways I'm glad I'm too old to see all that, because I'm not sure what it's gonna, I don't know. But it's getting, yes, the reality, there's also this thing, I'm not sure if anybody's ever heard of something called the uncanny valley. It's where you build robotics that get closer and closer to look real, but then they get to a point where they're very, very close, and suddenly people become horrified. You know, a doll, or you know, something, a child's play thing is cute, but these things that look real are like, ooh, this is like, it's a monster, like a Frankenstein monster. And we're radically approaching that spot with robotics, where we're building these machines that have such human expressions or capabilities, or look human even. It's very frightening. Or even dogs. You've seen these videos of dogs, robotic dogs, and it's like, you would never, what are they doing to that dog? Well, it's not a dog, it's a robot, but that's my dog, you know, you can't do that to, it's like, oh, I don't know, I'm scared, I guess. Yes.
So I have a comment, or something which was said here before, that sometimes technology is useless, or we have a lot of useless technology. But there's one idea which goes through almost all of your talk, is that technology, and computer technology, needs something like a sugar daddy, okay? Something which is a consumer's product, which pays to have people, clever people, creative people, all the necessary resources to develop stuff that will feed on and carry on this process on. And so I'm pretty sure that we don't need new computers to browse the web or stuff like that. But for sure, we do need an economical background of a large consumption, which frees money. Okay, so that we, and people in this room, and people everywhere in the world which are concerned with technology, have the means, okay, to be creative. Okay, and in that sense, I know from that from the story you told and from other stuff, that, for example, people from Palo Alto,
Yes.
from Xerox, who developed the mouse and the
Right.
Windows, they were graphical designers.
Yes.
They were creatives. So
Yes,
this was
they
not
were.
only computer people. There are people with skills from other fields, from creative fields,
Yes.
that brought in know-how, that brought in ideas.
Yes.
But for that thing to occur, they had Xerox selling out
Right.
all those copy machines, and
Yes.
people from Bell Labs selling out all those telephone stuff.
Right, yeah.
And I think what we need to be concerned about is how we can get new consumer products that pay off for all of this, that are truly useful to making this a better world. Okay? So that's the challenge, even for people who create technology, is not just to produce consumer technology which is going to feed in money, but
Yeah.
also make this a better place than we got when we were born.
Yeah.
Okay, so this is just the comment.
Well, no, you're right. As a historian, I have nothing but the greatest admiration for Xerox and for Bell Labs, but if I were a stockholder, I would be very upset because I would have lost all my money when the companies folded or something. You know, it's just a tragedy that Xerox has lost its independence, or Kodak is bankrupt. But I have, as a historian, it's like, oh, these people did these wonderful things. I don't know whether CERN will, you know, they were looking for the Higgs boson, or I don't care. You know, they invented the web. You know, great. That's something that wasn't part of their charter. But
there's an interesting thing. You spoke about the shareholders. I don't know if you know, but one of the main shareholders of Xerox was Lord Rank. And when he died, he took all his money and put it in a foundation
yes,
to science, technology, and so I'm not sure. I think in the end, he was happy
okay, good.
for
Good
his
for
money
him.
to go to all of this.
So I think we should thank our speaker again for this great seminar.